May I get in now? Good morning, ma'am. Good morning, sir.
Good morning. Please take a seat.
Thank you.
So, how did you come to Delhi?
Ma'am, I came from Bangalore to Delhi by flight.
Okay, so good. Yeah, can you just tell me how is Bangalore airport electrified?
Yeah, so before 3 years, most of the power is taken from the grid. Recently, they have introduced solar panels in the Bangalore airport. So now mostly like 50% of the energy is taken from the solar. So carbon emission is reduced by almost some 3,000 tons per annum.
Okay, all right. Right, so what is your job profile?
So basically, I worked as an analog design engineer for 4 years in Texas Instruments in Bangalore. So I used to design integrated chips for ultrasound equipment. So there we used to see a baby image.
Okay.
Yes.
All right. Fine. So, can you please ask?
Okay, Naveen. Generally, we use nodal and mesh analysis to analyze any network.
Yes.
So, can you solve every problem using nodal and mesh? What is the basic drawback of nodal and mesh analysis?
Generally, we solve most of the circuits, sir. But the thing is, when we have two sources, AC sources with different frequencies, so we cannot use nodal or a mesh analysis.
So, AC sources of with different frequencies.
Yes, sir.
If I have one DC source, one AC, can you apply?
Still, we cannot apply nodal and mesh.
Okay. So, how do you overcome this difficulty?
So, this we can solve by using a superposition theorem. So, one source at a time we have to choose and then solve.
Okay. Can you define the time constant definition?
So for a first order system, if system starts from 0 to let us say unit 1, so if the system response reaches to 63% of its output value, the time taken to it, we'll call it as a time constant.
Can you apply this time constant definition to any order like second, third? Can you apply or only
for the first order systems?
Why?
So second order system, the system response may go up and then come back and go up. So there may be a ringing and also. So even though there may be a multiple time constant, we cannot define a single time constant.
Okay. What do you mean by stability of the system? In a time domain, can you define stability?
Stability we can define by using theory called BO, bounded input and bounded output.
What do you mean by bounded?
So bounded input meaning like for input source at every point of time we'll be able to define amplitude of the signal. So that is called bounded input. So if you apply a bounded input, so output should be a bounded output. So if you don't apply an input, output should go to 0.
How do you measure the relative stability of a system using RH criteria?
So generally RH criteria we apply to know the absolute stability, whether poles are whether completely in the left hand side or right hand side by solving the equation and also looking at the first column of the
route table.
So if you want to know relative stability, we have to shift the axis from origin to the left side.
So how do you shift that j omega axis?
So we'll substitute S equal to S minus sigma 1 or sigma 2. So the sigma depends like how how away we are moving from the origin. Okay. And then from there we can figure out how relatively it is stable.
Okay. What is the advantage of Bode plot over Nyquist plot?
Bode plot, by looking at the plot we can directly say what is the gain crossover frequency and what is the phase crossover frequency. Okay. So if this crosses 0 line, and this will be a gain crossover frequency, and wherever it crosses 180 degrees, it is like we can directly look at the phase margin and gain margin from the plot.
What are the frequency domain specifications?
Frequency domain specifications are gain crossover frequency, phase crossover frequency, and phase margin and gain margin.
Define omega g.
Omega g is gain crossover frequency, where the plot is touching minus 180 degrees, phase plot is touching 180 degrees axis, so that is called gain crossover frequency.
Omega G is a frequency at which gain is equal to 1.
Okay. Oh. Okay. In dB it is touching
so
to
to
0.
find omega G, you prefer Nyquist plot or Bode plot, which is easy?
Bode plot is easy.
So can you ask?
Hi, Mr. Navin, I'd like to ask you a few questions based on electrical machines.
Yes.
Can you draw electrical equivalent circuit of a DC shunt motor?
Yes. So this is field winding of DC shunt motor, and this is armature part, and which I have represented as RA, which is armature resistance.
Of course. There would be a back EMF also,
Yes,
isn't
sir.
it?
Yes, sir. EB across this.
Yes, yes. Alright, very good. And I would like to know what were the basic methods we will apply to control the speed of a DC shunt motor.
So basically, speed of the DC shunt motor is directly proportional to the back EMF and inversely proportional to the flux,
Yes.
armature flux. So this back EMF is V minus IARA. So there are three terms: voltage, resistance, and flux.
Okay.
So we can control by armature flux, and also we can control by this is field flux, and this is armature terminal voltage, and this is armature resistance. So there are three parameters. So we can, by varying three parameters, we can control the speed of this.
Yes, of course. And also, can you tell me the difference between a power transformer and a distribution transformer? General definition.
So basically, power transformer is operated either fully loaded or like unloaded.
Okay.
But whereas distributed transformer is close by to the domestic areas, so it will be mostly on an average it will be loaded to 75% of its
Okay, because load is varying continuously.
Yes.
Okay.
So what happens is, the distribution transformer will be designed to get the maximum efficiency at that 75% of the load.
Okay.
So the thing is, to get the maximum efficiency, core losses should be equal to copper losses.
Okay. Yes.
So based on the load, core losses should be designed to get a 75 maximum efficiency at 75%.
Yes.
So we have to reduce the core losses to 75%.
Okay. During the design stage, core losses must be tried to minimize.
Yes. So for this we have to reduce the flux. So total flux is constant. So B max into A.
Yes.
So this is flux density. So to decrease the core losses, we have to decrease B max.
Yes.
Being flux constant. So obviously A will increase.
So size of the
distribution transformer will increase.
You are working in. I have seen this DA form. You are working in Texas Instruments Limited.
Yes.
Being an engineer, especially in R&D department, why do you want to shift your career to engineering services?
So in Texas Instruments, I was dealing mostly in analog electronics. So it is more of a communication side and electronic side.
Okay.
But whereas my entire education happened in electrical based side, so I want to move to electrical side.
Yes, that's a good question. Can you tell me how fax devices are going to be basically divided?
So
which areas we will use?
So in the present scenario, there is very less scope to increase the transmission and distribution capability based on the area capacity. But even though that is there, like power requirement is high. So to meet that power requirement, the flexible AC transmission systems are employed. So there will be static wear compensators like capacitors, inductors. So this basically to control the reactive power of the line. So if you want reactive power to be drawn from the line, you can put a capacitor which can supply the reactive power.
Okay. Perfect.
So can you ask?
Can you tell me what are the various equipments we find in a 132 kV by 33 kV transformer?
So basically, if we consider it as a step up like 33 by 132, so the name is just
No, I am asking you 132 by 33.
Okay, so 132 by 33 means like there should be a step down transformer, obviously from 132 to 33.
Can you tell me which connection it will be generally?
So basically it will be a delta star.
Delta star.
Yes.
Why can't it be star delta?
So basically, if you want to supply any single phase loads, then it has to be star.
Okay.
But as it is 33 kV, we cannot supply a single phase load. So basically, delta to Y transformer, there will be a 1 by root 3 times of voltage. You will get it for the phase.
Okay.
So you will get the less conductor size.
Means what you are concluding that?
So basically, size will be less.
Economy.
Yes.
Economy is a reason.
Yeah.
Why you will go for delta star?
Cost wise.
Or step up.
Correct.
Compared to step down.
Yes.
Okay. It's fine. How the distribution transformers will be? Which connection it is?
Distribution transformers will be secondary side. It will be star connected with a neutral ground.
With neutral ground.
Correct.
Okay. Next, can you tell me? I have asked you the earlier question.
Yes.
What are the various equipment we find in 132 kV, 33 kV? Substation.
So one is main step down transformer.
Okay. Next.
And then circuit breaker in series with a line to open and close if there is any fault.
Okay.
And then a CT to measure phase current.
For which purpose? Relay.
No, to measure the current, and if it exceeds nominal value, we can control using the relay purpose.
Okay. Next.
And potential transformer to measure phase voltage.
Okay.
And then there will be a lighting arrestor at the entrance and also at the outcome, like secondary side, to arrest the lighting surge that is applied on the line.
Lightning arrestor or switch is surge arrestor?
Both works in a similar way.
Both works in a similar. Can you draw the diagram? Surge arrestor. Schematic. Very simple.
It's basically a resistor, sir.
Okay.
So which will act only when it is a lighting surge. If it is a power frequency wave, it will act as a open.
Open. Yes.
And if it is a lighting surge, it will those contacts between those two line and the ground will get shorted, and the surge will be diverted to the ground.
Okay. Okay. I think you might have visited 132 kV, 33 kV substation.
Yes.
I have also seen. I have seen one transformer. Above that, I have seen one ring. Aluminum ring I have seen at some places. Many places it is.
Okay. So it is.
Which ring? Aluminum ring only.
Is it connected to a transformer?
Connected to transformer terminal.
Okay. Maybe.
Hollow aluminum ring.
Okay. I don't have clue right now, but I am thinking like maybe it might be connected to lightning surge or something.
Okay.
I don't have any idea.
Okay. Next, sir asked you to define the stability.
Yes, sir.
You said bounded input, bounded output. How you can convey that statement to our power network?
I didn't get the question exactly, sir.
Bounded input, bounded output is the thing what we are saying system is stable.
Yes, sir.
It means the system giving bounded output for a given bounded input system is stable. That's what we are saying.
Correct.
Can you tell me what is that input and output in our power network?
So in our power network, input is basically coming from an alternator for the power network.
Okay.
So output is coming from the alternator. Input is steam input.
Input is steam.
Steam.
What is the output?
Output is electrical.
Power.
So we have to always regulate steam input to get the proper electrical output.
Proper electrical power output. Okay. Whenever I have changed that steam input suddenly from a low number to very high number,
Yes.
then what happens generally?
So if steam input is suddenly varied, the rotor dynamics will change immediately. So there will be a certain range where that angle between the rotor flux and stator flux can oscillate between, and then there will be a margin. If it goes out of it, then it will become unstable.
Unstable. What analysis we have to do to analyze?
So
is it stable or unstable?
Analysis. One is steady state stability limit, other one is transient state stability limit. So steady state limit is like there will be a minor changes in the input side.
Okay.
Transient will be like sudden changes.
Which might be low among the two?
Steady state stability limit is like on the lower side. Transient stability will be like
if a system I have given a small disturbance on that.
Yes.
It is stable.
Yes.
Okay. Same system I have given a large disturbance.
Okay.
Will it become stable?
Depends on the house.
Okay. May or may not be.
Correct.
I have a system given a large disturbance.
Okay.
Stable.
Okay.
Small disturbance. Will it become stable? Surely.
Yes.
Then which limit will be low? Transient limit will be less.
Okay. Yes. Yeah.
Compare it to steady state limit.
Yes. Answer.
Okay. You will have one method to do transient stability analysis.
Okay.
Which method we will use?
It is equal area criteria.
Any other method we have to do transient stability analysis?
No, sir. I can't recollect now.
Solving swing equation?
Yes, sir. Yeah, it is a nonlinear differential equation. By solving the roots of equation
yes.
found by it, yes, we can.
These are the two methods, right?
Yes.
In your view or in your understanding, which method the people have invented first?
I'm thinking equal area criteria.
Okay. Can you tell me any disadvantage of equal area criteria?
I think generally it can be applied to a single machine or multiple machine, not like a multi-machine system we cannot apply.
We can't apply for multi-machine system. Okay. Next, any more can you expect? Okay. Thank you.
All right, Mr. Naveen. I think your hobby is cooking, is it?
Yes.
Right. So what do you cook?
So mostly I'll cook South Indian dishes, ma'am. Like there is a famous curry called Guttunkai curry. It's a brinjal curry.
Okay.
So I usually cook.
All right. Now, do you think that cooking helps in solving problems in engineering?
Absolutely, ma'am. Cooking dishes is like solving a problem in engineering. Because choosing a right quantity of ingredients is analogous to choosing right sources of whatever being provided to us, and we need to know like what is the right point of time when we have to use those sources to get the project outcome and also cost as a minimum.
All right. Okay, Naveen, your interview is over. You can leave now.
Thank you, ma'am. Thank you.